All right, Math 3 honors, here we go. Some more patterns for us. This video might actually be a little bit shorter than the normal videos on Monday, Wednesday, and Friday, but I just want to give you guys a little bit of help on two of these problems in the notes. So I'm going to go over example 1 and example 4. We already did example 3, and example 2 I'm actually going to do in a different video. So we'll start with example 1. All right, going through example 1. Again, we want to draw our fourth design. Hopefully that's not too bad of an idea, right? So we are just adding a block to each, the top and the bottom. Let me see if I can do this correctly here. So if that's our design 3, our design 4 will look something like this, right? With one extra block here, one extra block here, right? So now let's try to figure out the expression for this. Okay, so this is not easy, right? This is not easy, but let's look at this. We have here one block, we have here 3 blocks, we have here 5 blocks. So remember, we can't say, when we look at this, we can't say, oh look, design 2 gets you 3 blocks, so let's just say n plus 1. Because yes, that is correct for design 2, but if you look at design 3, you would have to say n plus 2, right? And if you look at design 1, you'd have to say just n. So this n plus is not actually going to work for this one. So we have to try and mess around with it. We have to try more and more, right? So a couple different things we can do. Let's try a couple here, right? So let's look at this. I'm going to erase those. Okay, so let's look at not all of the number of boxes, but let's start with just the bottom layer, right? This bottom layer is just n, right? So that's nice. Okay, so just the bottom layer is n. Okay, so we can, it's like, okay, we can do that, right? Now the harder part is, okay, well, this top is changing, right? This top is changing. So again, and we saw it in our yesterday's in Zoom as well, right? But this top part is changing from 0 to 1 block to 2 block. And again, there's a change there, right? So in order to get that, again, we are going to go with the 2 minus 1, right? And now again, if we look at this, let me go backwards here. If I take design number 1, when I solve this, I get 1. Yay. When I take design number 2, plug it in for n, I get 3. Good. When I take design number 3, plug it in for n, I get 5, right? And you can keep checking that, and you can check that for design number 4. So you would know your expression is 2n minus 1. Okay, and of course, looking at this next part, you would know, okay, well, that's a linear function, right? Because we know that the variable has an exponent of 1, right? So that's linear, right? And you can see it's even in mx plus b form. So again, I just wanted to kind of emphasize, like, okay, and I know some of you are thinking, like, oh, how did you get that, Mr. How did you get that 2n minus 1? Okay, so that's a great question. Again, that's just going to take practice and time. You're going to have to embrace the mistakes or embrace being wrong, right? You're going to have to try plugging things in. You're going to have to try like 2n minus 1, 2n minus 2, 3n minus 1, 4n minus 1, n squared minus 3, right? And you're just going to have to try different things, right? The big thing that you want to notice is when things are changing and when things are constant. Right? So let's go now down to number 4 here. So we're looking at number 4. We want to know when things are changing and when things are constant. Again, this one might be a little bit easier to see because we can break this up into pieces. Okay? We can break this up into, like, I don't know if we want to call this like the hallway, the room, and then the other hallway, right? So I don't know if that's how you want to picture it, right? But these are going to be my 3 different expressions, and then I'm going to make all the expressions together, right? So let's see the change of what's happening with just the first hallway, right? And again, it says number 1, describe the pattern. I'm going straight to the finding the expression. So I'm going to go straight to finding the expression. Okay, so I'm looking at just the hallway. Okay, well, just the hallway is not n, right? It can't be n because then there would only be one tile right here. There would only be 2 tiles right there. That's not the case, right? So it's n something, okay? So if I'm looking at this, this has 3 tiles. This has 4 tiles. This has 5 tiles. And I'm noticing, oh, okay, the next one's going to have 6 tiles. The next one's going to have 7 tiles. So this is n plus 2. N plus 2. N plus 2. Okay, so now when I'm looking at these different expressions, right? Okay, my first expression is going to be n plus 2. Now I'm going to go ahead and put that in parentheses. And I'm going to now add, right, my second hallway. So I'm going to start with keep going with the hallway. And there's a reason why I went with the other hallways now, or with the other hallways, is because we can think of this as 2 ways. You can notice, okay, well, I can say, oh, the same thing is happening. So I can go ahead and just put n plus 2 again, right? Or if I wanted to, and I'm going to go ahead and do this in dark green, I can say, oh, look, these are the same thing. So this n plus 2 is just happening twice. So if I wanted to, and I'm going to do this off to the side in dark green, I'm going to say 2 times n plus 2. And you'll notice if you distribute that 2, or if you combine like terms over here, you'll actually get the same expression. You'll get 2n plus 2, right? And remember, we're not distributing this. Don't distribute because there's a plus sign right there. So don't distribute, right? So this dark green is the same thing as the red and green together. Okay, so I'll just leave that dark green off to the side. If you like doing it separate, doing the red and then the light green, go ahead and do that. If you're like, oh yeah, I noticed that those are the same, the hallway to the left and the hallway to the right are the same, then you could say, oh, okay, I can do it the dark green way, right? And notice if you're looking at question number 2, it says write 2 different expressions. So you can even, if you're like, oh, I don't really get it, you can write both of these expressions, right? Now, don't forget about the blue. The blue is, I don't want to say the hardest one, but it's definitely not as easy as I think the hallways, because we have to notice something. I hope we can figure this out or notice it really quickly once I put the numbers, right? 1, 4, 9. Hopefully those numbers stick out to us. And if those numbers don't stick out, hopefully the shape of the blue sticks out, because these are all squares, right? Or perfect squares. So this next one's going to be 16. The next one after that's going to be 25, and so on. So this is just n squared, because this is just 1 squared, right? And I'll put it above the design number. This is 2 squared. This is 3 squared. And then 16 would be 4 squared, and so on. So we are going to add n squared to this, right? So there's our expression. There's one expression. If I wanted to make another expression really quickly, just to have 2 different expressions, I can take this n squared that I had, and I'm going to add this 2n plus 2. Now, I don't want you to think that I did some, oh, they look crazy how you did 2 different. They're actually the same thing, right? If you combine all the like terms in the left expression, you will get the same thing if you simplified the right expression, right? And, I can even write this a third way if I wanted to. I know this is probably going to get a little too confused, but I can write this a third way. I can go n squared plus 2n plus 4 and write it that way if I wanted to, okay? Now, I have no problem you writing it the gold way. The reason why I don't show the gold way is because it's not as easy to show each piece when you are trying to create the expression. I think either doing it the red, light green, blue, or the blue and dark green way, it's a little bit easier to okay, I'm breaking these designs apart and I'm showing each little part that I had and I'm adding them together. Okay, so this is just the notes that you have for today. Again, this right here, you do not have to finish to turn in. All you have to do is what we did just now. And then if you want, you can practice number 3, which is what we did in class yesterday. So that'd be good practice without seeing yesterday's lesson, right? And if you wanted to try example 2, you could as well and turn that in. And then the homework has more practice for you. So you can do that. All right. I'll talk to you guys later.